So page 25 and 26 in your packet, this is page 25, are the quiz review pages. So I'm going to do them on video now. For some of these exact value problems, I need my strategies on how I get them. Some teachers use the whole unit circle. Some people draw a table of values. Draw a table of values and memorize that. I like to use the special right triangles. So I'm going to take a second and draw those. And then for the inverse functions, we have to remember that for the unit circle, our inverse functions have restricted ranges. So for cosine inverse, we can only go 0 to pi. For sine inverse, we go from pi over 2 or down to negative pi over 2. So I include those values on my little sketches. Oops. To help me remember that I would never use 2 pi or 3 pi over 2 as an answer. Okay, so for now, that's a good enough start for finding my answers. So for number 1, it says sine of 5 pi over 4, and whatever the result of that is, I have to do sine of -1. I'm sorry, sine inverse of that result. So this is gonna say, what is sine inverse of? So 5 pi over 4 means I go to my pi over 4 angle. Sine is 1 over root 2. But then 5 pi over 4, if I think back to the first unit circle unit, 5 pi over 4 is in the third quadrant, so this is a -1 over root 2. So now going backwards, because this is a sine inverse problem now, I want to know, whoops, my pen hasn't been used yet. When is opposite over hypotenuse 1 over root 2? So I go to here's an opposite and a hypotenuse, so that's an angle of pi over 4. But sine inverse only has a range, or only has output values of pi over 2 to negative pi over 2. So since this is a -1 over root 2, I need a negative in my angle answer. Okay, so now tangent inverse of 1/2. Looking at my pictures, and tangent, which is opposite over adjacent, there's no opposite and adjacent that is 1/2. So this problem can't be done with our special right triangles or our unit circle, and instead I have to draw my own triangle. So tangent is opposite over adjacent, and if this is my angle, so opposite over adjacent, I need to use Pythagorean theorem to find out the hypotenuse. So 2 squared plus 1 squared equals radius, or hypotenuse squared. So that is the square root of 5. So since the tangent inverse output is an angle, so all of this is an angle, I'm going to use the picture I drew with the sine ratio. So sine of this picture is 1 over root 5. Okay, so then for 3, for opposite and hypotenuse, neither of those values come from a picture. I don't have any opposite with a hypotenuse of 3. So that means, again, I have to draw my own picture. Sine inverse is negative in the fourth quadrant. So this is down 1 with a radius or a hypotenuse of 3. So to get my x value, x squared plus -1 squared equals r squared. So this is the square root of 8. So cosine of this picture is root 8 over 3. Okay, so lastly for 4, again, I'm never going to have an adjacent and a hypotenuse of 3 for my special right triangles, so I'm going to draw a picture. Cosine inverse is negative in quadrant 2. So this is adjacent over hypotenuse. So to get my y value, y squared plus x squared equals r squared. Y squared is 8, so this is a root 8 again. So then tangent of this picture is opposite over adjacent. So that's root 8 over negative 1, which is negative root 8. All right, so that was page 25. Now to page 26. It looks like for most of these, all right, at least for the beginning ones, I'm gonna need my special angles again. So number 1 is saying, what angle gives me a sine value of negative 1? So that's gonna come from my quadrantals because there's no opposite and hypotenuse that are the same. So sine is the y coordinate, that's down here. So negative pi over 2 is my answer. Okay, cosine, if I think of this as 1 over 1, there's no adjacent and hypotenuse that are equal from any of my pictures. So instead I'm gonna go to my quadrantals and think, where is the x value positive 1? That's here. So this answer is 0. But now tangent, that's different. When tangent equals negative 1, or the angle that gives me a tangent ratio of negative 1, there is an opposite over adjacent that are the same. So this angle answer is pi over 4. But because of the negative ratio, that's down here in quadrant 4, I'm going to make a negative angle. Okay, so for number 4 with cosine inverse of 1/2, that's asking when is the adjacent over the hypotenuse 1 over 2? So it's saying adjacent and hypotenuse. So here's a leg and a hypotenuse of 2. So adjacent to this side is pi over 3. And that's the answer because it was a positive ratio. For 5, inverse sine of 1. So when is the sine output 1? Well, it's similar to number 1, but instead of being down here at negative pi over 2, it's up at the top at positive pi over 2. And then for 6, I think of root 3 over 3 as 1 over root 3 because that's the way I have my sides labeled. I don't have the denominator rationalized. So this is asking when opposite over adjacent is 1 and root 3. So here's my 1 and root 3. Opposite of the 1 is pi over 6. But a negative ratio for tangent puts me at a negative angle. Okay, for 7, it's a 2-step problem. Cosine inverse of negative 1/2 is saying, okay, so what is adjacent to 1 with a hypotenuse of 2 is pi over 3, but cosine inverse negative is here in the second quadrant. So I'm going to think of pi as 3 pi over 3 and go backwards by a reference angle. So this inside value is 2 pi over 3. So now I'm going to evaluate what is cosine of 2 pi over 3. So I go cosine of pi over 3 is 1/2. 2 pi over 3 is in the second quadrant. And since sine is the only positive function, this is a negative 1/2 answer. Okay, for 8, what angle gives me an opposite over hypotenuse of root 3 over 2? So opposite root 3, that's pi over 3. So then it's saying sine of pi over 3 is opposite over hypotenuse, so this answer is root 3 over 2. This root 3 over 3 I'm going to think of as 1 over root 3 again. So tangent, what angle gives me an opposite of 1 and an adjacent of root 3, so that's pi over 6. And then tangent of pi over 6 is opposite over adjacent. Okay, last, oh no, we got 6 more. Okay, here we go. Cosine inverse of cosine pi over 2. Okay, cosine of pi over 2 is this x coordinate up here at 0. So then it's saying what angle gives me a cosine value of 0? Pi over 2. So this is sine inverse. So sine of pi over 4 is 1 over root 2. What angle, so now this part's for the inverse, what angle gives me an opposite over hypotenuse of 1 over root 2? It's pi over 4. Tangent of pi over 3 is opposite over adjacent. So now what angle gives me an opposite of root 3 with an adjacent of 1? Is pi over 3. It's opposite and adjacent. Okay, so for these last 3, I have to draw the triangles like the last few on the warm-up on page 25. Because there's no opposite and hypotenuse that's 1/2. Oops, sorry, I knocked my phone stand. So for 13, sine inverse positive ratio means quadrant 1, opposite over hypotenuse. Oh, no, Miss Weiss, that's silly. Opposite over hypotenuse, that's an angle of pi over 6. The others I need. Okay, so this is saying cosine of pi over 6. So cosine of pi over 6 is root 3 over 2. So now for this one, an adjacent and hypotenuse, there is no adjacent of 3. So now I'll do 14 here. Adjacent and hypotenuse, well, now that's an interesting problem. We can't have an hypotenuse shorter than a leg. So watch what happens. If I do x squared plus y squared equals radius squared, and I subtract the 9 to keep solving for the y, I get y squared is -5. You can't have a square root of a negative. You can't have an imaginary number as the side of a triangle. So this problem does not exist. There is no answer to 14. Let's try 15. Opposite over hypotenuse. So let's see, x squared plus y squared equals r squared. This one will work. X squared is 6. So this side is the square root of 6. Here's my theta. So then tangent of this picture is opposite over adjacent, which is root 3 over root 6. You can leave that as an answer. It kind of bothers me to do that because the individual square roots works as one big square root, and 3 over 6 reduces. So this can be the big square root of 1 over 2, but then the square root of 1 is 1, so I'm going to say 1 over root 2 is my final answer. I'm pretty sure on the quiz tomorrow we would accept this as an answer as well. I like this one, it's reduced. Make sure you can do these 2 pages without hesitation and you will be ready for the quiz.